Dear students, welcome to virtual classroom of Municipal Corporation of Greater Mumbai. I am Sreekumar. The class is for 9th standard students. Subject is mathematics. Let me begin the class.
So my dear students, we are reaching to almost the last video of explanation of real numbers. Actually, the chapter 9 real numbers is something wonderful because you started learning about numbers right from class 1, and you studied about numbers 1, 2, 3 and named it as natural number. Then you studied about whole numbers where 0 was added. Then you studied about integers. Then came to the concept of in between integers numbers are there, and we started studying about rational numbers. After studying about rational numbers, we had a lot of experiments with that, or we started doing operation with the addition, subtraction, multiplication of all such numbers. And later we found that even there are certain numbers which are named as irrational numbers, which was the main dealing of this chapter. And we found that those numbers which are non-terminating and non-recurring, we named them as irrational numbers. And when rational numbers and irrational numbers, when completed, we came to know that there are no more number system available. Our number line became almost each and every point on the number line covered. So while doing the operation of rational numbers, we were quite clear about how it goes about. When it came to the irrational numbers, as the name indicates, irrational they are. Rational is having a meaning quite reasonable. There is no rational means there is no proper rules are not able to apply, but as mathematicians worked upon it further, developed certain rules in order to apply the mathematical operations in this kind of numbers, and came to know that we have to classify them separately and classified as surds. Just at the end of the last video, you should have gone through the last video so that you will be in a position to understand the concept of what we say irrational numbers, and the concept in this video what is named as surds. Then what are surds? It's a new term for you. Whenever we talk about numbers, we simply kept on adding numbers. Now comes a new term that is called surds, but it is quite connected with the concept of, or it is just an explanation of irrational numbers. And understanding surds is just for the sake of what are surds. Operations are of irrational numbers only. Let me try to make you understand. You know that 5 is a rational number. Root 5 is not a rational number. That means it is an irrational number. Root 25 is a rational number, right? And fourth root of 5 itself is a root 5 itself is a irrational number. If you take fourth root of it, that also will not be a rational number, that will be an irrational number. And if you think that how can we represent such numbers which are irrational or rational irrespective of its root, so we can simply say nth root of a can be anything and n can be any number. It can be rational or irrational. Suppose that n is an integer and a is a positive rational number. Positive rational number means above 0. Integer means it will be 1, 2, 3, 4 or minus 1, minus 2, minus 3. That's why all these number system just I recollected before starting surds. So n is an integer means it can be a negative number or positive number, but it cannot be numbers like fractions, like rational number. But a is a positive rational number means rational number can be negative, but here in this case of its root we are going to take is a rational number, and nth root of that particular rational number, suppose we name it as x. This is for the purpose of understanding what we are trying to explore here. So nth root of a is equal to x. This is what is the concept of it. Then, and what we get after doing nth root of a, and if we are getting a irrational number, we call this as surd. What is that? Nth root of a as surd, because x is a irrational number. X will be the value of nth root of a, correct? I will explain you with an example. That means surd is an irrational root. A root, when we take, if we get irrational, we call that number as surd. For example, if you are taking integer 2 and that is a positive number, you know that. Nth root means we are taking simply square root of it. That means square root, when there is no any special mention, it is square root. So we are taking square root of 2, and we know the answer is an irrational number, 1.4111, something like that. It goes, correct? So in this case we found that it is an irrational, and we know this, and the value of root 2 is a surd, because it is a irrational number. So root 2 is a surd because its value is a irrational number. And also you should know from this particular screen or particular page, I'll go a little slowly but thoroughly. From this page also you should know, certain terms you, that means nth root of a is equal to x, and if this x answer, when we found, if this happens to be an irrational number, we call nth root of a as surd. This is the concept. Clear? Now in this particular setup we call this sign as the sign radical sign, just for understanding. The naming is only for that purpose. And n over here, this is called order of the surd. This is order of the surd. Understood? And this, what is inside, is called radicand. For future, when you study further maths in 11th standard. Okay, so this much is clear. So a surd is an irrational root. Root 2 is a surd, root 3 is a surd, root 5 is a surd, and all I said root because we are taking the order 2 here. Cube root of 5 is also a surd. Let us try some example in that respect. For example, suppose that if I am saying a is equal to 7, n is equal to 3, and then cube root of 7. We know that 7, we have root 7 will be having an irrational answer. Naturally, cube root of 7 is also an irrational number, and it is a surd, because the answer of cube root of 7 is an irrational number. This much you should understand at this stage. Okay, let me take another example. Suppose that we are having 27 and I am taking cube root of 27, and the answer is 3, and it is not a irrational number. That means cube root of 27 is not a surd, because the answer is not irrational. Understood? So we will say that cube root of 27 is not a surd. Understood? Concept of surd is clear now. We can take one more example. Fourth root of 8, and the order is 4 here. Nth root means what is that? N is the order, and if you find it is not a rational number, because when we try to solve it, we will solve it and get that fourth root of 8 is not a surd. Is a surd because we will get the answer as irrational. Now what we have to conclude, surds of order 2 is also called quadratic surd, and your chapter will be dealing with only quadratic surd. That means the order will be 2 and 2 only. That means n will be always 2 throughout the chapter. So we are going to learn on mainly about quadratic surd in this chapter. Surd is an irrational root, and in this case cube root of 7 is a surd, root of 5 is a surd, root of 3 is a surd. Understood? This way you should understand the concept of surd. Let me move ahead. So what is surd is what is said by this much time. Surd can be in simplest form. For example, if you are having a surd like this, root 48, we will check that whether it is a surd or not, and we found that it can be simplified in this way. And for root 3 cannot be further, we cannot get the answer. It will be rational. So for root 3 will be rational, and it is a surd. Surd. What is a surd? Root 48 is a surd, and the simplest form is, this is the simplest form of that surd. Correct? 98 if you are taking 49, root 2 49, we have 7 root 2 will write, and that way. So root 2, root 3, root 5, root 7, these are all what is just like the simplest form possible, because further we cannot find out the root of such, because all those are irrational numbers, and naturally the matter ends there, and we have to write them as simplest form. There is another concept in your textbook, what is called similar surds. What are they? Similar surds are just like a polynomial. We are having same variable. Similar surds, that's almost same like that. Root 2 and minus cube root of 2, 4 upon 5th root of 2. What I am trying to show here is all these are having root 2, root 2, root 2, just like x, 3x, 4 upon 5x. So they are like or similar surds. They are like or similar surds. That is one concept of similar surds. This is just like pth root of a, qth root of a, means they are also similar surds. Suppose whether 45 and 80 are similar surds, oh, ये तो अजीब question हो गया. Then we have to convert them into simple form. Just like earlier, 9 into 5, here it is 16 into 5. Further we will do 9, root of 9 is equal to 3 root 5, and this is 4 root 5, and we found that this root 5 is like surds there, or similar surds there. So we used two things. We converted them into simpler form, and we got the answer and found that they are similar surds. Another concept is about comparison of surds. Comparing the surds, which is bigger, smaller. We use the notation A smaller than B. If it is like that, if you are multiplying both sides with A, we know that again A square will be, see, I'm just writing fast. A square is smaller than AB when A is smaller than B. And if I multiply with B, then AB will be smaller than B square. This is known to you. Suppose that we are considering these two equations where we got A square is smaller than AB, B square is greater than AB, because we multiplied both sides with B. In such a situation, we can simply substitute by A square is smaller than B square. And if the matter is here, A is smaller than B, here I am writing A is bigger than B, then that case what happened? A square will become bigger than B square. And if it is equal, these all are applicable for why A and B are brought over here. All these principles are as it is applicable for surds also. In the case of surds also, this concept of A smaller than B, that means A square is smaller than AB. If A bigger than B, in that case, if we are thinking about A square will be bigger than AB, and in that way everything that we studied in the case of rational numbers are applicable in the case of surds also. Okay, let me go ahead. We continue with comparison of surds. We need to practically compare 6 root 2 and 5 root 2. There is no problem. We know that 6 root 2 will be bigger, correct? Because 6 into root 2 it is. 6 root 2 means 6 into root 2. So 6 root 2 will be bigger for sure. And 5 root will be smaller. But if in the case of 5, instead of 5 root 2, if it is 5 root 5, we will get into confusion. Root 5 and root 5 is slightly bigger than root 2. Naturally, whether root 5 will be bigger. For this, we need to develop a technique. We can either bring this 6 into a square format and write root 36 into 2, because root 36 is 6, and here it is root 25 into root 5. So this all became, now we can multiply. Here we can write root 72, and here we can write 25 into 5, 125. Now we know that this one is smaller than this, so we will write simply 72, root 72 is smaller than root 125. Naturally 6 root 2 will be smaller than 5 root 5. 5 root 5 bada ho gaya. Understood? Or we are having another method. The method is slightly different. If you square this, isko square kar denge. Look here. So 6 square and root 2 square, again you will get 6 square is 36 into 272, and this will be, it is a two-step method, and we will write that 6 root 2 is smaller than 5 root 5. This way also you can solve the sum. Understood? Okay. Let us go ahead. Another example for comparison. If this way it is, we will convert it into root 64 and we will do as it is done now, and we will get 192 on both sides, root of 192 equal. So we will write that 8 root 3 and root 192 are equal for our wonder. If you are taking another example here, 7 root 2 and 5 root 3, we will write instead of this 49, here it is 25, and we will substitute that, and 98 and 75 we got. 98 is naturally bigger, so we will write 7 root 2 is bigger than that of 5 root 3. So this way we do, what we are doing is comparison of surds. What are surds? Surds are irrational roots. Roots of certain numbers are irrational. We call those roots as surds. And just like any other number, as I told you at the beginning, we studied about natural number, whole number, then integers, then rational number, irrational number. What we did was operation on that. What is that operation? Plus, minus, multiplication and division. So we are familiar with what is meant by operation in. The next one is simply, we know that whenever we get familiar with certain numbers, we do start operation on that, normally starting with addition and subtraction. Here is an example for a situation like if I simply, just for recollection, 9 plus 16, if I add this, we will simply write it as root 9 plus root 16, correct, which is equal to, we can write 3 plus 4, which is equal to 7. This is our method of addition of simple square roots. The same is applicable here. Suppose that we are having a surd like this, 7 root 3, we have to add with 29 root 3, similar surds. We are talking about similar surds. So in that case, what we will write in the next step, we will simply write that 7 plus 29, then we will be simply write root 3 here, and the answer will be 27 plus 9, 36 root 3, no problem. If it is similar, like sometime it won't be similar, we have to find out whether anything can be done so that it will become similar or it is similar. For example, if there is a addition of surds given like this, root of 20 minus root of 125, these are to be added. In that case, we find that these are not similar surds, at least by appearance, but we can simplify it. 8 root 5 will remain as 8 root 5 because root 5 is an irrational number. Root 20 can be written as 4 into 5, and sorry, this is not minus, it is plus. Okay, minus root of 125 can be written as 25 into 5. That means in the next step I can write 8 root 5 plus root of 4 is 2 root 5 plus root of 25 5 root 5. Okay, now it became just like before. These are similar surds. We can simply add 8 plus 2 plus minus 5, not plus, here it is minus, so 8 plus 2 10 minus 5, so you will be writing the answer 5 root 5. So this way we can do addition and subtraction of such surds, or we can simplify such numbers or expressions. Understood? Let me go ahead. There can be multiplication and division also in this format. If you are thinking about multiplying the surds, we can carry out multiplication also. Again, about similar surds, we are thinking about multiplication and division of it. If you are thinking about root 7 into root 42, simply multiply, and we can say that this 42 can be written into 7 into 6, and we are getting a pair of 7. Naturally, we'll write 7 root 6, and it is an irrational number. There is no guarantee that whether it will be rational or rational. Irrespective of that, we will do this multiplication like this. Sometime it will be rational, sometime it will be. Regarding division also, we can carry out in this format. 125 upon 5, root of 25, and the answer is 5, and which is a rational number. It can be rational, it can be rational also. Sometime it will be as simple like this: 50, root of 50 into root of 18, suppose. So what we will do, what we can do, 50 can be written as 25 into 2, right? And 18 can be written as 9 into 2, and we can further write that 5 root 2 into 3 root 2, correct? 5 root 2 into 3 root 2. Interestingly, 5 3s are 15. Root 2 into root 2 is 2. Naturally, the answer is 30, which is a simple rational number. So ultimately, we have to say that the answer can be rational or irrational depending upon the numbers. Okay. Next topic is rationalizing the denominators, or rationalizing the surd itself. Rationalize means making it reasonable. P upon Q format में बनाना है. For example, here is a surd for multiplication root 2 into root 8, and we can solve this in a very different way. Suppose that it is equal to root 16, and we write that in a rationalized format. This is rationalized. Root 2 is an irrational number, it's a surd. Root 8 is also is a surd, but when both multiplied, we got root 16, and we got a rationalized number. So by multiplying root 2 with root 8, we could get a rational number, or we rationalize root 2 by multiplying with root 8. Otherwise, root 8 can be rationalized by multiplying by root 2. Rationalized means we made it and converted it into a rational number. For example, this is a surd, this is also a surd. On multiplication, we got an expression root 16, which is not a surd because the answer is 4, and it is a rational number. This way, we can convert surd into a rational number, or we can rationalize it by multiplying with suitable another surd or number. Okay. This will come in use whenever we are trying to solve a problem. Root 2 is a rationalizing factor of root 8, or root 8 is a rationalizing factor of root 2, by which the irrational nature of root 8 and root 2 will get over, or which will be removed by multiplying. So they are mutually rationalizing. Okay. Another example, root 2 into root 6. So what we can write, root 2 into root 6 can be written like this, and unfortunately we cannot get any this one. When it became 4 into 3, there is no need of 1 second, there is no need of this root 2 over here. This root 2 is not required. It is simply 4 into 3, and 4 is having its own, what we say, square root 2, and the answer is 2 root 3, and we did not get a rational number, but we are multiplying. So that is possible in certain cases. Here you see root 2 into root 50, and it is root 100, and we got 10. So root 50 is the rationalizing factor for root 2, or for root 50, root 2 is the rationalizing factor mutually. You can go for more examples in this to understand the concept of rationalizing factor. If it is a root 27, we can write it as 9 into 3, and we know that it will be 3 root 3, correct? So 3 root 3 is not a rational number. Then we need to multiply 27 with, because root 27 is not a rational number. So we will be multiplying 27 with certain numbers so that it will become rationalized. If you multiply 27, which is 3 root 3 now, with root 3, it will become 9. So root 3 becomes rationalizing factor of 27. Understood? Not only root 3. This is a rationalizing factor. If you multiply 27 with root 3, it gets rationalized. The number becomes rational. Anything like root 3, for example, root 27 into root 3, we know that it will become a rational number. Even if you multiply with 3 root 3, then also it will become rational, because it will be 3 times of that rational number, but what we get. So that means this root 3 is the basic rationalizing factor as far as 27 is concerned. That is the concept here. So rationalizing factor is a very important concept in order to solve certain difficult numbers in future when you deal with mathematics. In future, when you deal with mathematics means when you study mathematics. Rationalizing is a very important aspect. And normally we don't keep root, irrational numbers, etc. in the denominator. So we use this rationalizing technique in order to solve certain situation where denominator is not that easy to deal with. So we remove that, or we change the denominator into a rational number. For example, here is a denominator which is root 5. 1 divided by root 5. No, we don't want that division. Root 5 is a divide karna. We have not studied at all. So we will convert this root 5 into 5 by multiplying both the denominator and numerator with same number. That means this will rationalize the denominator. What is rationalizing? Root 5 is rationalizing, and we get the answer like this. That means we rationalized the denominator, and we got the idea of rationalizing just now. Another example, 2 root 7. Again, what will be the rationalized? So we will do one thing. We will multiply 3 upon 2 root 7 with root 7, not with 2, not with 7. That 7 is the issue there. So we will multiply with root 7, both numerator and denominator, and convert that into a rationalized. Yeah, that means convert the denominator, which was 2 root 7, into a simple rational number, which is 14 now. Now you can solve in your own way. Understood? So denominator can be rationalized by multiplying with suitable rationalizing factor. Understood? This you should know, and exercise is there. So here root 7 is the rationalizing factor. No need of 2 root 7 multiplied by 2 root 7, only root 7 is sufficient. By attending this much in the video, you can pause here, go back, re-attend, restudy, and try to understand. I was taking textbook example only to explain, because you can follow the textbook. Textbook is the mother book where you have real syllabus and real examples. I have explained it in my own way because textbook won't explain to you. Someone should explain to you. The point over here, you can pause the video here and go to exercise number 2.3 if you have understood everything, or you can go back in the video and again come back and get the idea about what the topic is, what is the concept of surds, how can we deal with operations. Little more is remaining in the chapter. I will be just continuing. You can continue with the chapter later on another day if you feel this much is enough, and I will do 2.3 exercise. 2.3 exercise is the most important exercise in your textbook of this chapter. So I am going ahead to explain you the concept of binomial quadratic surd. Binomial means polynomial, binomial, trinomial. There are two. This one I am doing it fast because this is simply a connecting binomial nature of our numbers with our newly discovered surds. Anyway, I will explain. I just wrote it fast because to save time and length of video. This is a binomial expression. Understood? Two surds are the binomial, correct? Quadratic means having order 2. Not to forget. Surd means the answer is a irrational number. So there are two surds having order 2, that means square root, and it is a surd. So these all are binomial. Root 5 minus root 3, 3 upon 4 minus root, all these are binomial surds and binomial quadratic surd. Suppose that if you think about another situation, root a plus root b into root a minus root b, a rationalizing factor like situation, but we know about a plus b and into a minus b, which gives a square minus b square. The same way we can write root a square and root minus b square. What will happen here? In this case, the answer will be a minus b, because a square, root a square is a, root b square is b. Suppose that the first one which we have taken as example, just once you have to understand, root 5 plus root 3, just like root a and root plus b, root a minus root b, just like that, root 5 minus root 3, a square minus b square, 5 minus 3, answer is a rational number 2. So when we made a product of this binomial surd, we got a rational number. So whichever that number, it was given root 5 plus root 3, we multiplied with root 5 minus root 3. This converted this root 5 plus root 3 into a rational number. So we call these two as conjugate pairs. Conjugate means which can pair, which can unite, which can come together and give a new product. That is the concept of conjugation. So conjugate pairs will give a new answer, new product, here it is a rational number. So they are conjugate pairs. They go together and they give a new product. Okay, so that is one concept which is there beyond 2.3 in your textbook. Another further about conjugate pairs, the rationalizing concept of denominator is applied here. See, we are having a number like this. We want to rationalize the denominator. Denominator we will not keep like this, or neither we will keep in any other format. So what we will do, we will think about how to rationalize the denominator by applying conjugate. The conjugate of 3 root 2 plus root 5 will be 3 root 2 minus 5. So we'll apply that. That is the concept. How we will copy the question as it is. Okay, we will multiply with the conjugate pair. Okay, now it came in the form of a plus b whole square and a minus b whole square. So we will substitute 8 into 3, 24, correct, root 2, and 8 into root 5, 8 root 5. These two are like a square minus b square, we wrote it. Understood? In that case, 3 square is 9, root 2 square is 2. So it will become 18. So we will do the operation accordingly. This one is as it is. Below that we will write 18 minus root 5 square is 5. And we can write 18 minus 5 is 13. We reach to this stage. That means we can convert a very complicated irrational number into this format with the denominator rationalization, with the denominator which is a rational number, with the help of the concept of conjugate pairs and rationalizing denominator. When these two together we apply here, plus conjugate pairs concept and rationalizing denominator concept, when both apply together, we could derive a reasonable or a rationalized presentation of an expression like this. Okay, we will go ahead. The last concept in the chapter is about absolute value. Absolute value, you have heard the word when we are studying integers. Integers are those numbers, both negative and positive numbers, which you studied, and we found that minus 4 and 4 are having absolute value. We write absolute value with the help of two vertical lines and the number inside. We wrote it as 4. I used to tell at that time, if you had been my student at that time, if you are moving to right side 4 centimeter from 0 or moving left side 4 centimeter from 0, both are 4 centimeter. That means the quantity is 4. Absolute value is 4. But to denote that it is left, we write minus here, and without writing plus, we can say that it is to the right side. But both are 4 centimeter. Quantity is 4. That quantity is expressed as absolute value. And the concept of absolute value, which you applied in the case of integers, as it is applicable in the case of the all real numbers. What are real numbers? Real numbers are numbers, rational number, integers, whole number, natural number. All these numbers are coming under real number. Real numbers का definition क्या है? Rational plus irrational, both together. That is what we are doing now. So in this case also, whether it is minus x or plus x, whether it is minus x in the sense a negative real number or positive real number, the absolute value of that will be x and x only. Same principle is applied in the case of real numbers. So my dear students, I am closing the video here. I know that video is a little heavy by information and knowledge. You can watch the video again and again, but you cannot escape from the knowledge. That means the knowledge should go inside. Keep your textbook open, listen to the video, keep a pen in the textbook. Most of the things are taken from the textbook because textbook is a product of a big research. Examples also like that. Examples are examples because it will help you to solve sums in the textbook, as well as it will help you to solve many other sums which comes from outside. So my dear students, go through this video once again. It is not easy, I know. Go and also know that the video is quite lengthy for you, because this much of information together will jam your brain both way, traffic jam and making brain into a jam. Just joking. The point over here is that you should not consider that hey, मुझे समझ में नहीं आया इधर तक आने के बाद क्या मुझे कुछ problem है क्या? No, there is no problem with you. The topic is like that. Your textbook also I found it very difficult to make the students understand what is so टेक्स्ट बुक बनाने वाले भी बहुत मुश्किल से एक्सप्लेन करके देख रहे कैसे बताओ. Simply understand there are certain roots which are having irrational expression. We call them as surds. But when we take the root of a number and it becomes irrational, we call that root as